before we jump to the next topic, let's solve this congruence equation. So we have a 4x plus 1 is congruent to 5 modulo 12. So what we need to do here is to find a remainder of 5. And we have to check for x until from 0 to 11 since our modulus is 12. So let's start now kasi madami-dami siya. Plus 1 is equivalent to 5 modulo 12. This will become 1. Okay, 1 cannot be divided by 12. The remainder is 1. So this is not a solution. 4 equals 1. 4 times 1 plus 1 is congruent to 5 modulo 12. So this is 4 plus 1 is congruent to 5 modulo 12. 5 congruent to 5 modulo 12. So obviously this is a solution. So 1 is a solution. Pares na sila eh. 5, 5. So 5 divided by 12 is a remainder. You will get a remainder of 5. X is 2. So 4 times 2 plus 1 modulo 5 is congruent to 5 modulo 12 rather. Sorry. So 4 times 2 is 8 plus 1. 9 is congruent to 5 modulo 12. Let's verify. 9 divided by 12 cannot be remainder of 9. So this is not a solution. Remainder of, what did I say, 9 here, remainder of 5. 0 is not a solution. 2 is not a solution. So x is 3, so 4 times 3 plus 1 modulo 12. 4 times 3 is 12 plus 1, 13 is equivalent to this. So 13 divided 12 is 1, remainder of 1. So 3 is not a solution. So what are our solutions so far? We only have 1. Let me erase this. But take a look at the pattern. So we're getting these types of remainders. 1, 5, 1, 5. Let's see if it repeats. Baka magamit natin yon to our advantage. So where are we? We are at x equal to 4. So x equal to 4. 4x, or 4 times 4 plus 1 is congruent to this side of the equation. 4 times 4 is 16 plus 1. That is 17. Now, is that a congruence? 17 divided 12, you will get a quotient of 1, 12, 13, 14, 15, 16, 17. Yes, a remainder of 5. So, indeed, 4 is a solution. So, remainder of 5 again. So, x equals 6. No. X equals 5. 4 times 5 plus 1. This side of the equation. 4 times 5 is 20 plus 1, 21. Let's check if it is a solution to the congruence. So basing on the pattern, maybe the remainder will be 9. So 21 divided 12. 12 times 12, that's 12 times 2 is 24 already. So quotient of 1, remainder, what's the difference between 12 and 21? 13, 14, 15, 16, 17, 18, 19, 20, 21. Yes, remainder of 9. So this is not a solution. So basing on the pattern, this is for 0. This is for 1, 2, 3, 4, 5. So here are my solutions so far. So if I substitute 6 to the left side of the equation, I'm expecting a remainder of 1. 7, a remainder of 5. So 7 is also a solution. 8, 9, 10, and an 11. So if I put 8 to the x, the remainder will be 9, 1, 5, and 9. 10 will also be a solution. If you want to verify that, please help me and do so. 10. So these are my solutions, all less than 12, which is the modulus. So if I add 12 to them, I will be able to find other solutions. So 1 plus 12 is 13. 4 plus 12 is 16. 7 plus 12 is 19. 10 plus 12 is 22. And you will be able to see that we are skipping by 3. Ano po? So 1, 2, 3, 4. Every third number is starting from 1. Every third number is a solution to the congruence. So how about the concept of additive inverse? Remember, in regular arithmetic, when we say additive inverse, these are two numbers and their sum of the two numbers is 0. So the additive inverse, kabaliktaran, diba, when we say inverse. So 8, what will you add to 8 that will result to an answer of 0? Of course, it's additive inverse, which is the negative 8. Okay, so how do we use this concept of additive inverse in modular arithmetic? How does the same concept apply? So what is the number that can be added to 3 such that this congruence will be true? If I divide that by 8, kasi I'm working in modulo 8 arithmetic, the remainder will be 0. And it has to be less than 8. So obviously it's 5. 3 plus 5 is 8. 8 divided 8 is 1, remainder of 0. What are the other numbers that can be divided by 8 tapos remainder ay 0? 3 plus 13 will also make this congruence true kasi 13 plus 3 is 16 divided by 8, that's 2, remainder of 0. But that's not the correct additive inverse because the additive inverse have to be less than the modulus. So it has to be smaller than the modulus. So this is 13 is not the additive inverse of 3. So in other words, you just have to add something to 3, the smallest whole number to 3 that will give you an answer of 8. So it will be 5 in this example. So here you are looking for 7 plus x that will make this congruence true. So you see a 16 here. Ano, i-add ko sa 7 to make it 16. So 9. It's quite simple, okay? Now, how about this? 6, what will I add with 6 that will make this congruence true? So obviously it will be 6 as well. 6 is less than 12, so that's correct. 6 plus 6, that's 12. Now, how about multiplicative inverse? Now, if in additive inverse, that's the number that if you add two numbers that if you add together, it will result to a product of a sum of 0. In multiplicative inverse, I have to multiply two numbers and the product will be 1. Okay, so if I have a 2, what will I multiply by 2 such that the answer will be 1? So usually a fraction, ano po, 1/2. Because if you multiply the numerators and then you just copy the denominator kasi wala siyang katapat doon sa ilalim. To divide 2, that's 1. Okay? that means that the multiplicative inverse of 2 is 1/2 and vice versa. The multiplicative inverse of 1/2 is 2. Now, how do we apply the same concept in modular arithmetic? So in this example, we are looking for an x that when divided by 5 will make this congruence true. So looking for a remainder of 1. We are looking for now a remainder of 1 here if divided by the modulus, in this case a 7. So we cannot substitute 2, for example. X cannot be 2 kasi that will make it 10 modulo 7. The product, 10 divided 7 is 1, remainder of 3. So, remainder 1 ang hinahanap natin. And we are successful in doing that if we substituted 3 because this will be 15. Now, 15 divided 7, that will be 2. 7 times 2 is 14. Our remainder is 1. So, this one is correct. So, what we are looking for is to solve for this this equation, this form. Ano po? What would be the x that you will multiply with a such that if divided by m, the remainder will be 1. So here it was done again. So again, we are looking for a number less than the modulo. So 7 in this case. The numbers that we can substitute to x will be from 0 to 6. Yun yung ginawa nila dito. Or they started at 1 in this example. Okay. So here in modulo 7 arithmetic, find the multiplicative inverse of 2. If you will put that in equation form, so 2x is congruent to 1 modulo 7. This is a modulo 7 or a mod 7 arithmetic. So they started at 1. So 2 divide 7, that's 0, remainder 2. 4, 2 times 2 is 4, divided by 7, 0, remainder 4. 2 times 3, that's 6. Still, remainder, quotient of 0, remainder 6. 2 times 4, now that's 8, divided by 7. Quotient of 1, remainder of 1. So, the multiplicative inverse of 2 in mod 7 arithmetic is 4. Okay? So, 2, if you multiply that by 4, that would be 8. And that will make this congruence equation true. So here, find the multiplicative inverse of 5 in mod 11 arithmetic. So we're looking for a multiplier to 5 such that this congruence will be true. Let's start at 0. Okay, so 0, that would be a remainder of 11. 5 times 1. So 5 divided by 11, that would be a remainder of 5. So this is not true as well. 5 times 2, 1 modulo 11. So that's 10 divided by 11. So still not a remainder of 1. 5 times 3 is 15. If we divide it by 11, quotient of 1, remainder of 4. 5 times 4, that's a remainder of, that's 20 divided 11. So that would be 1 remainder of 9. Okay, so this is taking a long time enough. 5 times 5, that's 25 divided by 11. 11 times 2 is 22. So this will be quotient of 2. Remainder of 3. 5 times 6 is 30. 30 divided 11. Kasi 11 times 3 is 33. So this is 2. Remainder of 8. Okay, finally I was able to find it here by multiplying 5 times 9. That's 45. Okay, so I think the shorter method to do this is to think of the multiples of 11. Diba, we have 11, 22, 33, 11 times 3, 33, 44, and then the multiples of 5, 5, 10, 15, so on. Until we get to 45, which when divided by 11 ay ano po siya, 4, 11 times 4 is 44, remainder of 1 to make it 45. So that means that the x here should be 9. Okay?